All right, guys, what we're going to do is we're going to take a look at the day 3 size of the sun. This is something we did in class. And the first thing I want you to do is, if you've got your packet or booklet and you're working on this at home, put that right up here and draw a line right through the center like that. And draw a half circle. Another half circle on the outside like that. And then connect this half circle right up through here. And from the edge, connect another half circle right out there. And what this is this is a cutout of our sun. So in the center of our sun, we've got our core right here. Coming off the core, we've got all this energy. And this is a peek into what we think our sun might look like inside. And so we've got the core in the center, and then we've got a bunch of what we call convection happening on the outside, which is cooling goes down, warming goes up. So you could put a few things like this and all sorts of great stuff. So this is kind of just a look into our sun. If we were to take a chunk out of it like this, what it would look like. Okay, next thing I want you to do. We're going to put our planets right up next to our sun here. And to do this, we're going to look right up here, and we're going to set up our scale. Now, scale has to do with whenever we want to make a model of something, we have to create what's called a scale. And so to create a model, if I wanted to create a model of something, I would take the actual size of something, and I would divide it by, remember a line can be divided, divide it by my model size. The model size of what I want to do. I want to make a model of something. So up here at the top, I've got the sun's diameter. This is the actual size of our sun. Divide that by my scale over here. And so if I look over at my sun next to here, I'm at 13 as a diameter all the way across. It's 13 diameter. The true diameter is here, but I want my model to shrink down to 13 like this. So actual size on top, this is my model size here. And now I need to find my scale shrinking number. So what I'm going to do is I'm going to divide these two out. So I grab a calculator like this, and I take my actual size, 1,392,000, divided by my model size, 13, and it gives me a big number here. So I'm going to write this down. 107,070. Let's take that 9 right here in the tens place. Since it's 5 or more, let it soar. We're going to bump this up. We're going to round this up, this 6, because there's a 9 right there, to 77. Let's round that up to the nearest whole. Remember how to do that. So this is now our special number that we got, and I call this number our shrinking number, because any actual size divided by the shrinking number shrinks it down. Isn't that weird? So Mercury's actual size is 5,000 kilometers. But I'm going to shrink this down to my model over here, because I want to put Mercury over here on this small little diagram. So I need to shrink it down. So I'm going to divide it now by my shrinking number right there. So it looks like this. I take 5,000. I divide it by 107,077, and it equals 0.04. Let's round to the hundredth place. This is the tenths, this is the hundredths, this is the thousands. Let's round to the hundredths place. So 6, 5 or more, let it soar, bumps this up one number to round. So 0.05 centimeters. How do you graph that? Let's take a look at this over here. On my ruler, I've got, right on here, a bunch of little spikes. In fact, let me show you this really quick. I'm just going to turn my page to a blank section real quick so I can just show you something. On this centimeters here, I've got a dash here, and then all the way over here I've got 1. Think of that 1 centimeter as $1, for instance. Think of it like that, like a dollar. So this is 1.00. That's my 1 centimeter. In between here, I've got these little slashes called millimeters. Each slash, 1, 2, 3, 4, 5, 6, 7, 8, 9, is a tenth. Well, Mr. Jensen, that kind of makes sense. Each of these little slashes is like 10 cents. And if I added 10 cents 10 times, I'd get to $1. 1. That's it. These are your tenths place. And if I looked even closer, which is really difficult, so I gotta zoom in here. I can't see on here, but imagine that we had 10 little tiny slashes inside here. 10 little itty bitty ones. Each of these little bitty 10 slashes in here would be like a penny. 0.01. Holy cow, 0.01 would be those little tiny slashes. So again, if I was to draw this bigger, like this would be 1 centimeter here. This would be like $1. And I could put 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slashes between it. Each of these would be like 10 cents, 20 cents, 30 cents, 40 cents, 50 cents, 60 cents, 70, 80, 90, and $1. And in between this, I could put 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 little slashes, and each one of these would be a penny. Like that. So if I had $1.31, let's say, I would go all the way to $1, and then I would keep going 30 cents, 10, 20, 30, like that, and then I'd count one little one in between that next one. So if I had 1.31, it would be all of this to here. That's 1.31. Let's go back here. We've got it here. We've got 0.05, so 5 cents in a weird sense. 5 cents, or 5.05 centimeters. But we're going to pretend like it's 5 cents. So I'm going to come right over here, and I'm going to draw Mercury. I'm going to spell it right here. Mercury. And then I'm going to get right inside here. And I'm going to draw this 0.05. So 0.05 is just a tiny little dot, like that. There it is. It's half the distance to that first line. Mercury. That's how big Mercury would be if we put it right against the sun. Beep. Tiny. Venus, Earth, Mars. We put Ceres on here, which is just a little tiny thing. It's kind of fun, a little dwarf planet inside the asteroid belt. And then we've got Jupiter, Saturn, Uranus, Neptune, and Pluto, all across here. Create a scale model of this all the way across. Go ahead and pause your video. What would this thing look like in the end? In the very end, you're going to see something like this. There's the size of Jupiter, Saturn, Uranus, Neptune, Pluto. Ceres won't even show up, it's so tiny. Mars, Earth, Venus, Mercury are going to look like this. So against the sun, if we were to shrink the sun down to 13 centimeters, that's how big our planets would be. Look how small Earth is compared to the sun. Holy cow. That is a crazy scale. There's the numbers if you need to look at them, just to check your numbers with my numbers if you're curious. You can pause this video. Check your numbers. Okay, and then the last thing was right in here today. And what we did is we set out a tape measure, and we did a standing broad jump to see how far we could jump when we measured the back of our heels. So if I jumped 30 centimeters, 35 centimeters, and 34 centimeters, I can find the average. I add up the total of jumps right here, which actually isn't 33. That should be in a different line. I add these babies up. So I go 30 plus 35 is 65. 65 plus 34, 60, 70, 80, 99. So this would be 99 centimeters total, would be my total if I added them all up. Then I come down here and I divide this by 3. 99 divided by 3. 9 divided by 3 is 3. 9 divided by 3 is 3. 33 centimeters is my average. So I put my average down here all the way down. And then I start to divide by the gravity. And when I do that, it's going to give me in inches how far I could jump. So I could jump 33 centimeters on Earth, but on the moon I could jump 194 centimeters. If you want to know how much that is in feet, divide it by 12, because 12 inches. Oh, I'm so sorry. I put in centimeters. This should be inches. What am I doing? I switched to inches because we had our... Sorry about that. This is inches. I switched to inches because we had inches on our tape measure. So that's really confusing. We were just talking centimeters. These were all in inches. So 194 inches was my jump. Divided by 12 inches, which is a foot, I had 16 feet. If I was on the moon, I could jump 16 feet. On Earth, I can only go 30 inches. So quite a difference. If I go all the way down to Jupiter, which Jupiter is kind of freaky because I'm 723 pounds, as I said in the last video. I take a jump on Jupiter, and I put in my 33 centimeters here on Earth, divide it by the gravity of Jupiter, 2.87. Yep, I could clear 11 inches, barely. Not very good. 11 inches, 700 pounds. Not doing so well. Jupiter's massive with a lot of gravity. Okay, there's the two things that we did today. We created our planets, and we did this right here.